Assalamualaikum and good afternoon to my lecturers and all my friends. My name is Nur Shazwana binti Suhaimi with my partner Muhammad Taqiyuddin bin Anwar. We are from Group T. Today, we would like to present about Chinese remainder theorem. So, let's start with history of Chinese remainder theorem. Chinese remainder theorem is discovered in a 3rd century Chinese mathematical theoretist. It is called Sunzi Xuanqing, the mathematical classic of Sunzi, which the author is unknown. Now, Sunzi Xuanqing is known as the Chinese remainder theorem. We can find this theorem in Chapter 3, Problem 26 of Sunzi Xuanqing. In Chapter 3, Problem 26 of Sunzi Xuanqing, there is a problem which is now there are an unknown number of things. If we count by 3s, there is a remainder 2. If we count by 5, there is a remainder 3. If we count by 7s, there is a remainder 2. Find the number of things. Besides of the problem, the author of Sunzi Xuanqing also provides the answer and the methods of the solution. The answer for this method is 23, and we use the method. If we count by 3 and there is a remainder 2, put down 140. If we count by 5 and there is a remainder 3, put down 63. If we count by 7 and there is a remainder 2, put down 30. Add them to obtain 233 and subtract 210 to get the answer. If we count by 3 and there is a remainder 1, put down 70. If we count by 5 and there is a remainder 1, put down 21. If we count by 7 and there is a remainder 1, put down 15. When a number exceeds 106, the result is obtained by subtracting 105. This theorem has evolved into a systematic theorem that can easily be found in many elementary mathematical texts.
Okay, let us start with having two deck of the cards here. Okay, so we are going to put the first deck here into sequence where the number A here is actually referred to number 1. The second one, 2, 3 and 4. So we are going to put it into sequence like this. And for the second deck, we are going to put it in a reverse order, where we are going to start from the highest number that we have here, which is 4, 3, 2, and A here we can consider it as number 1. Okay, let us put it into these two groups. Okay, so what I'm going to show here is, okay, we are going to do a very simple tricks, okay, where let's say we try to close all the deck that we have here. Okay, and we are going to do the shuffling of the cards. And here the shuffling of the card is quite unique, where we are going to shuffle it by this way, where we are going to use the first card at the top, and we are going to shuffle it to the bottom. Okay, bring it to the bottom. So in this tricks, I'm going to use the 11 shuffling. Okay, so let us try to do it. You can do the shuffling for both cards together. Okay, you can choose which card you need to, or which deck you want to shuffle. Okay, let's try to do it. Okay, so I need your help, okay, to choose which card you want to shuffle. Okay, maximum of the shuffling, or we need to shuffle it 11 times. Okay, which one you want to shuffle first? Okay, this one. Okay, shuffle first. Number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so let us see the what happened. Okay, if we take the top of the card from each deck. Okay, so let us put it there. Okay, now we are going to do again the same process where we are going to shuffle it 11 times. So I need your help again. Okay, to choose which one you want to shuffle. Okay, the first one, 1, number 2, 3, 4, 5, 6, 7, 8, 9. Okay, last one, 10. Okay, let us see.
11.
10. Okay, one more. Okay, sorry. One more.
11.
11. Okay. Thank you very much for reminding me. Okay, let's take the top of each deck. Yeah. Okay, again, 11 times. This one. Okay. This one or this one? This one. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, let us see it here. So we only left with one deck there. So I think we just put it like this. Okay, hopefully you can get the magic there. Okay, let's try to open the first one. So if you see here, okay, you are going to have the same number for each cards from both deck. Okay. Okay, maybe there's a just the coincident part. So let's go for the second one. See, we still get the same thing. Okay, and we really hope that the magic can continue there. Okay, let's see here. Okay, we get the same one, and for sure, I think the last part, we still get the same thing. Okay, so how does this thing can happen? So I'm going to explain it mathematically after this. What we are going to do, we are going to convert the situation of shuffling there into the clock. So if you look into the clock in at your wall there, basically the movement, okay, will be start from the value of 1, 2, 3, and so on so forth. So here we are going to deal with the same thing, where we are going to start with our red deck there. So if you look here, we have our red deck. I want to change it into the red clock here. So here we are going to get here the first one. The first number that we can get here is the ace, okay, which is, it can be represented as number 1. You can get here the second deck, which is the number 2, number 3, the third card, so and so on so forth. So if you bring it into the rotation of the clock, you are going to get something like this. So if you try to continue up until a very large number of cards, if you try to generalize it, okay, maybe I'm going to put it as the value of m, where we can see that m is actually the total number of cards. So let me put here, the value of m is equals to the total number of cards. So in our case just now, the value should be 4. So if you want to reduce the number, we are going to use it as m minus 1, m minus 2, and so on so forth. So this is if we try to continue. Okay, so this is, we are going to arrange this card in ascending order. So on the second card, the opposite card there,
we try to arrange the card based on the descending order, where the number that we start is very large number. So in this case we have the number 4 there. So in order for me to generalize it, maybe I'm going to use also the same number m, which is it represents the total number of card. So you can get here m, so it will goes into m minus 1, and if we try to continue, you are going to get here m minus 2, and you can go straight up until you get 1. Maybe you can start with 3, 2, and the last part you are going to get 1 there. So if you continue your calculation there, so here we can also write the number of shuffling. So for the red card here, let's say, because the position is on the left, so I will put it as the left shuffle. And for the black card here, because the position is on your right side, so let's put it as R shuffle. Okay, if you still remember what we did in the tricks, is that we try to shuffle it 11 times. So what we can get here is that the value of L plus with R will be equals to 11 movement or 11 shuffling. Okay, so if we try to shuffle it in the left part here, okay, in our circle here, we can actually will try to start with 1, the first shuffling, second, third, and it will come at the end as L plus 1, because this is the L shuffle, so we are going to end it up until L plus 1. So if we go for the right shuffling, so we will be m minus 1, m minus 2, m minus 3, and so on and so forth, up until we are going to end it up until m minus r. So here we can see that the value of L plus 1 and m minus r here is actually represent the top of the card for each deck. Because if you still remember the situation that happened just now, once we finish shuffling it 11 times, we are going to get the results there. So we can see that the L plus 1 there represent the top of the card of the red deck, and m minus r represent the black deck, the top of the card at the black deck. So here we can see that the value of L plus 1 and m minus r is actually same. So we can say that L plus 1 is your top of the first deck, and m minus r is your second deck. So let's say the value here is 4, so your second deck also will be 4 there. So in order for us to show it here, basically we can start with the equation that we have here, L plus R equals to 11. Okay, so here, since the value of L plus R equals to 11 here, we can actually try to use another magic number, which is, I think we have learned about the modulo there. So we can cancel the number 11 here. We can change it into L plus R will be the modulo of -1 mod n, mod m, where the value of m, as we already mentioned just now, is the total number of cards. So in our case here, we can say that the value of your L plus R is congruent to the -1 modulo 4. Okay, so here, because I want to make it general, so I will put it as m there. So let us stick with the value of m here. So L plus 1 is equals to M minus R. So based on the calculation that we have here, okay, I write it here because maybe after this I'm going to drag it down. So L plus R is now is the congruent to -1 mod M. So here when we see here we have the L plus 1. So we can say that the value of L that we have here, we can change it into L equals to minus R minus 1. So which is, we can change it into L plus 1 is actually equals to minus R minus 1. And because we have plus 1, don't forget you are going to get plus 1 here. So the plus 1 and plus 1 here, you can cancel it off so that you can get here, it will be equals to the negative R, and of course this is actually mode of M, and we can actually find the equivalent value of negative R here, which is, we can say that the L plus 1 is equivalent to M minus R mod M. So we can say that yes, the numbers should be the same based on our calculation just now. Okay, next part. Okay, here we are going to see why we choose 11 shuffling move and 4 cards there, because if you still remember that I use the mode of the congruent of -1 mode M for the calculation. If you still want to go it back here, I'm using the value of -1 there. So here, because of that, okay, we are going to get the 11 shuffling move there. Because if we want to use the Chinese reminder theorem, okay, I will see RT there. Since the number of cards that we have there is 4 for each deck, so we can say that we can get here X is congruent to -1 mod 4. This is the first part because we still have 4 cards. And after that, okay, after we finish shuffling it 11 times, if you still remember, we are going to shuffle it again 11 times, but now the number of the card already reduced to 3. So we are going to get into another equation, which is we still stick with the -1. So here we are going to put it as mode 3. And then we are going to further the same process where we still stick with the -1, and we are going to put it as mode 3. And here we can actually try to solve it by using the Chinese reminder theorem. The difference that the Chinese reminder theorem that we have learned in class is basically, sorry, this is supposed to be 2. The value of your M, the mode there, should be co-prime. But here, since we have 4 and 2 is not co-prime with each other, so we actually need to deal with what we call as non-co-prime Chinese reminder theorem. So this is not my intention to elaborate on it. But here, if we try to solve it, basically we can get the value of X is actually referred to the value of 11 there. So here, the value of 11 here actually referred to the move that is relevant with our card 4. Okay, that's why we choose the value of 11.
For conclusion of Chinese reminder theorem. The famous Chinese reminder theorem managed to raise much interest from the mathematicians in antiquity. To give commentary of it in their respective treatises due to the unelaborate explanation given in Sunzi Suanqing. We should be given credit to Muslim mathematician Ibn Tahir for cracking the unresolved mystery posed in Sunzi Suanqing since 31st century. Through the Muslim mathematicians, the Chinese reminder theorem spread into the works of the European mathematicians. That's all from Group T, Wana and Taki. Thank you.